Hello again. This is Math 1220 coming to you from the College of DuPage. The title of this lecture is Verifying Arguments Using Logic, and this is the fourth lecture in our logic series. As always, please be an active learner while you watch this video. At the end of this video, you'll know how to use truth table to show that an argument is valid, use truth tables to verify arguments, recognize some common valid argument forms, and recognize some common fallacies. Let's begin by talking about verifying arguments. So we'll consider a collection of statements produces a logical conclusion. Instead of expressing an argument in sentence form, we will represent it symbolically and use truth tables to determine whether it is valid. The following is a simple example of an argument. If Mihaela passes the bar exam, then she is qualified to practice law. Mihaela passes the bar exam. These two are above the lines, and we say, therefore, Mihaela is qualified to practice law. This argument begins with statements 1 and 2 that are called premises, and ends with the final statement 3 called a conclusion. If the two premises are true, then the conclusion must also be true. Another way of saying this is that the conclusion follows from the premises. At least if it's a valid argument, that will be true. Now we will use truth tables to determine whether arguments are valid or invalid. Again, some more formal definitions. An argument is a series of statements called premises, followed by a single statement called the conclusion, and this line separates the two. An argument is valid if, whenever all the premises are true, then the conclusion must also be true. So let's use a truth table to determine whether the preceding argument is valid. So what we're going to do is we're going to change it into this form. Mihaela passes the bar exam is going to be P, and Q is she is qualified to practice law. So the argument becomes if P, then Q, P, draw the line, therefore Q. So these premises and the conclusion. So we will set up a truth table to see if it does follow from that. So we will set up a truth table with, this is P and Q. This is if P, then Q. This is P and Q. So what we're going to do is we're going to cross out everywhere where one of these premises is not true. So we cross out this one because the if P then Q is not true, and we also cross out this one because P is not true, and we also cross out this one because they're both not true. So this is the only line which both premises are true. And because the conclusion is also true, the argument is valid. You can ignore the other lines, and in fact you do not need to compute them. Because true premises never lead to a false conclusion, this argument is valid. The form, if P then Q and P implies Q, is called the law of detachments. Note we have proved not only that this particular argument is valid about Mihaela and the bar exam, but also that any argument having this form is valid. So if we have if P then Q, P, therefore Q, we're calling that the law of detachment. At least in this book we call it the law of detachment. So this is our approach then to verify an argument. We verify an argument as follows. We make a truth table with separate columns for each premises and one for the conclusion. Examine only the lines in the table in which all the premises are true. You can think about crossing out the others. If the conclusion is also true for the lines you examined in step 2, the argument is valid. If the conclusion is false for any of, even one of the lines you examined in step 2, then the argument is invalid. Let's do another example to determine the validity of this argument. If you buy the more expensive Hula plan, then you can watch TV commercial free. You cannot watch commercial free. Therefore, You did not buy the more expensive hula plan. We're going to let E stand for the more expensive hula plan, and F represent you can watch TV commercial free. So this argument has this following form. If E, then F, not F, therefore not E. So I make a truth table with E and F. E implies F, not F, and see what we have. And we cross out all those where any of the premises are not true, but this is the only line in which both premises are true, and because the conclusion is also true, the argument is valid. So this argument is valid, and in fact, you might notice that this kind of reminds you of the contrapositive, and this argument is an example of what we will now call the law of the contrapositive. So when you see an argument that fits this form, E implies F, not F, therefore not E, that is valid, and that is the law of contraposition. Now, some arguments are invalid, and if a truth table has an argument, a line in which the premises are all true, but the conclusion is false, then the argument is invalid. Let's look at some examples of invalid arguments. So we're going to determine whether the following arguments are valid or not using the process that we outlined. If I have a new calling plan, then I can text my friends for free. I can text my friends for free, therefore I have a new calling plan. Okay, well, we're going to let C be I have a new calling plan, and F represent I can text my friends for free. Then we have the argument that is symbolically if C, then F, F, therefore C. So we build this truth table, and we look at the condition where all the premises are true, but we see that this third line we have true and true, but we have a false conclusion. So that means that this is an invalid argument. And later on we'll give a name to this argument. Let's look at number B. If the moon is made of green cheese, then Taylor Swift has sold more than 100,000 digital albums. The moon is not made of green cheese. Therefore, Taylor Swift has not sold more than 100,000 digital albums. Well, this time we're going to let G represent the moon is made of green cheese, and T represent that Taylor Swift has sold more than 100,000 albums. So the form of this is if G, then T. Not G, therefore not T. Now this sort of looks like the inverse, which we found out was not equivalent to the main statement, and so let's build a truth table and find out what happens. So we'll force both of the premises to be true, and we notice that again in the third line we have a true and a true for the premises, but we have a false for the conclusion. That means the argument is invalid, and soon we'll have a name for this argument. So anytime you see if C, then F, F, therefore C, that is not a valid argument. The one that we found in 2A is called the fallacy of the converse. And we talked about that looking like the converse, so that's why that is called the fallacy of the converse. It is not a valid argument. And part B illustrates the invalid argument that's going to be called the fallacy of the inverse. It is important to stress that the form of an argument is more important than what the argument is actually stating. And arguments are also found in one of several standard forms. The ones across the top are going to be valid arguments. The two across the bottom are invalid arguments. So, the law of detachment, if P then Q, P therefore Q is valid. That's called the law of detachment. If P then Q, not Q, therefore not P is called the law of contraposition. That is valid also. The law of syllogism, which we did not prove, but this says if P then Q, if Q then R, that means therefore if P then R. That's called the law of syllogism, and this is called disjunctive syllogism. P or Q, not P, therefore Q. Those are all valid arguments. This is an invalid argument. This is the fallacy of the converse. If P, then Q, Q, therefore P. That is not valid. And the fallacy of the inverse. If P, then Q, not P, therefore not Q. Let's look at some examples now where we identify the form of an argument to see if it's valid or invalid. So the first one says, if you want to improve fitness, take up cross-country skiing. You take up cross-country skiing, therefore you want to improve your cardiovascular fitness. Well, we can change this into this form, and we see that this is I implies C. C, therefore I. This is invalid. It's the fallacy of the converse. In number B, if you sleep through your morning math class, then you will be well rested. And if you are well rested, then you will do well in your math exam. Therefore, if you sleep through your morning math class, then you will do well in your math exam. So we change these things into variables to see what the form is. This is if S, then R. If R, then W. Therefore, if S, then W. So this is a syllogism, and this is valid, even though the reasoning seems to make no sense. You really want to attend your math classes when you have the opportunity to do so. Now, you may have been surprised that the argument was valid even though it didn't make any sense, and please understand that it's the structure of the argument that determines validity or not validity, not the content. Let's look at a much more complicated example where we have three variables. If we balance the budget or reduce taxes, then there will be more money available to fight pollution. If we do not balance the budget, then we will not reduce taxes. Therefore, we will not reduce taxes. Or, excuse me, that's a premises also. We will not reduce taxes. So these three are our assumptions, and then we say, therefore, there will be more money to fight pollutions. Okay, so we take these to be the following form. So this is B or R implies M. We've got three variables there, you know. And negation B implies negation R. We also have negation R. So we force all of these premises to be true and see if that forces M to be true. So we build a truth table. Now we know that there are 8 rows, so we have to build that, and we have to compute all the premises. So this is our premise 1, this is our premise 2, and this is premise 3. And I force all of them to be true. That means I cross out any places where any of them are false. So I get these 3 lines, all the premises are true. But in this case, it's false. That means the argument itself is invalid. So the argument is invalid, even though 2 of the 3 are true. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. We're all in this together. May God bless you all.